Redwood Manager is the web-based interface used to control, commission, and report on the lighting and sensor network. It is accessible through any standard browser that is connected to the corporate network or internet. Let's start with the dashboard, which is used for reporting on energy usage, occupancy, and temperature at the building level. The default report is total power consumed in watts. It is important to note that Redwood Systems is the only company to measure actual total energy consumed, including any power used by the platform, so you can accurately measure and verify energy savings for rebates or lead credits. The user can select a different time period such as weekly, as seen here, or a different report such as light level, which illustrates the benefits of daylight harvesting. Alternatively, one may view motion and power together to understand how occupancy impacts power consumption in a location. The dashboard also displays real-time temperatures by location in Fahrenheit or Celsius, in addition to displaying custom alerts relating to fixture issues, out-of-band temperatures, or security alerts for unauthorized access. The Control tab indicates what policies are in place for a location and enables temporary overrides. Initial policies are set up in an administrative tool. For this location, we see the lights are set to operate at 85% of maximum, our best practices policy. Daylight harvesting is enabled, and the policy is based on occupancy, where the light will automatically turn off after 15 minutes. Creating lighting policies is straightforward. Not only can you set a maximum light level, but also a minimum light level, as seen here. Minimum light levels are often used in hallways during early evenings to save energy, but still provide a feeling of safety. We also see these settings in data centers, where lights can be dimmed to a minimum of 10 to 20%, so security cameras can still operate while energy savings are maximized. Lighting policies are typically based on occupancy. The Redwood Systems platform has a standard occupancy mode where the user defines how long until the lights turn off after no occupancy is detected. The code requires 30-minute timeouts, but we see clients being more aggressive by moving to 10 minutes or less. The reason they can do this is that they are confident the high-density sensor grid will not have the lights go off when their space is occupied. In contrast, most other systems have one sensor per room or zone, which is why lights often go out when occupied. The user can select how quickly the lights fade and turn on. Based on customer feedback, there is a policy called multi-sensor occupancy. This rule requires 2 or 3 sensors to trip before turning on the lights. The use case is typically an empty conference room with interior glass, where a passerby might create a false positive by tripping the sensor closest to the window. There is also a vacancy mode, as some states require the manual turn on and off of lights when entering a space. And finally, there is Follow Me Lighting mode, which we'll demonstrate shortly. The Reporting tab is where you view the impact of various lighting policies. Currently, we see the total watts used in this room is over 400. Initially, we're going to enact our best practices policy of running the lights at 85% of maximum. This results in a relatively small decrease in light level that is barely perceptible, but results in about a 30% reduction in power consumption right off the bat due to the efficacy of LEDs improving disproportionately when dimmed. Not only does this save on energy costs, but it also extends the life of the LED as it runs at a lower temperature in a dimmed state. Now we're going to use daylight harvesting to capture light from outside and have the lights automatically dim while keeping the same ambient light level in the room. This is generating another 30% of energy savings, as you can see here. Redwood Systems is able to measure light levels at each sensor and control fixtures individually, so only the lights closest to the windows dim to save energy, but do not cause all the lights to go down and potentially disturb the occupants. The final energy savings technique we are going to show is a lighting policy we invented called Follow Me mode. This is ideal for hallways or data center aisles where traffic can be periodic. The lights can be off or dimmed to very low levels when no one is present, and then brighten as each sensor is tripped. As the person passes by, the lights immediately fade out by design. As you can see, this provides another 10% or so impact on power consumption. If we then add a baseline to show how much energy would be used by a typical fluorescent system without controls, we see the dramatic savings enabled by Redwood systems. Thank you for viewing this short demonstration on building performance lighting. For more information, visit www.redwoodsystems.com.